So in this video, we're going to talk about adding, let me go over here to my black pen. Okay, adding and subtracting polynomials. Okay, so when you see this topic in Alex tries to teach it by having you do like lots of stuff that you don't need to do. So the most important thing is that when you add and subtract polynomials, you can only combine like terms. Can only combine like terms. So for instance, right, if you think about this in words, if I said, oh, I have 3 apples plus 7 pears plus 2 peaches minus 5 pears plus 3 apples, right? And I wanted to kind of put stuff together. Notice that all together I have 6 apples, right? I have 3 apples here and 3 apples here. So all together I would have 6 apples, right? I have 7 pears and then I'm taking away 5 pears. Maybe I gave them away to friends. So I'm left with 2 pears. And then the peaches, right? There's only 2 peaches and nothing else. So I can't put them with anything and I would have 2 peaches. And when we talk about it in terms of words, usually people don't get too confused because they're like, oh, that makes sense to me. And I would never combine apples and pears and peaches. They're all different. So it's the same thing if I did it with a polynomial. So if I had something like 3x squared plus 7x plus 2 minus 5x plus 3x squared, then my x squared here in this term and in this term, the x squared part, that's like my apples. The x part here, that's like my pears. And there's not a variable here, so that's like my peaches. And so I can only combine the things that have, when we talk about like terms means that the variable parts, the variable and the exponent have to be the same. So that's the important thing to remember. Like terms means the variable and exponent must match. So if I think about here, I have the 3x squared and the 3x squared. So that's going to give me 6x squareds. I have the 7x's and the minus 5x's. So that would give me 2x's. And then the only other thing I have left is this plus 2. So I'm just going to have plus 2. So that's my final answer. I cannot combine anything else together because all of the things that are left, right, they're all different. They're not like terms because this has an x squared, this has an x, this has a 2. So again, I have, apples go with apples, right? Pears go with pears. This peach here is all by itself. The peaches is all by itself. So same deal. So let's try some of these. So for example, perform the operation. So A. Sometimes you're going to see them written with parentheses around them. So 7y squared plus 2y minus 9 plus a negative 3y squared minus y. So since there's a plus sign in between them, right, I don't need to really do, whoops, went to the other side. I don't need to do anything, okay? So what I'm going to do here is I'm just going to rewrite it. So I have a 7y squared plus 2y minus 9 Positive times a negative is just a negative, so minus 3y squared. Positive times a negative is just negative, so minus y. And so now if I look, here I have a y squared term, and here I have a y squared term. So 7 minus 3 would give me 4y squareds. Here I have a y term, that 2y, and here I have a minus y. So 2 minus 1 is going to give me a positive 1, so positive y. And you could write 1y here if you wanted to. But remember, you don't have to write the 1 in front of a variable, so it's okay to not write it as well. And then the only other piece I have left over here is this minus 9 piece. So I'm just going to write that as minus 9. So I'm going to rewrite it without that 1, so just 4y squared plus y minus 9. So we'll do some more examples here. What about B? Whoops. Things sliding on me here. So B, 25m to the fourth minus 23m to the fourth plus 14m. So just like we've done before with numbers, we have to distribute this negative to both of these pieces. So this is going to become 25m to the fourth minus 23m to the fourth minus 14m. And now if I look, the pieces that are alike, here in this first piece I have an m to the fourth, and this second piece I have an m to the fourth. So if I put them together, 25 minus 23 is 2m to the fourth. And then this 14m is all by, minus 14m is all by itself. So I'm just going to subtract off 14m. And that's it. You can't put anything else together because nothing else goes together. Here's another example. So maybe I have 2ab squared plus 9a squared b minus b squared plus 7ab squared minus 3ab plus 7a squared b. Okay, so again, the first thing I'm going to do, since there is an addition sign here between the two, I'm just going to rewrite it without the parentheses. So 2ab squared plus 9a squared b minus b squared plus 7ab squared minus 3ab plus 7a squared b. And now I'm going to look for things that are like terms. Now remember, like terms, all the variable pieces have to match. So this first piece here, it has an a to the first power and b to the second power. So I'm going to go looking for all the things that look like it. So this second piece, right, the a is squared, so it doesn't work. This piece, the b is squared, which is good, but I also need an a, and this doesn't have an a, so that doesn't work. But here, this piece is another a to the first power, b to the second. And then my other two pieces, right, there isn't that. So if I put these together, the red pieces, I would have 9ab squareds. And now I'm going to look at the next part, right? So the next part, this has a squared and then a b. And if I look, this doesn't work, this doesn't work, but this one has an a squared and a b to the first. So I can combine that one. So I have 9 of them plus 7 more of them would give me 16 a squared b's. If I look at this third piece here, it's a b squared, but the only other thing that's left is this piece, and it doesn't have a b squared. So this is just going to be minus b squared. And then finally, this last piece here, right, it's a minus 3ab, And there are no other AB terms, so it's just going to be minus 3AB. And then that's it. I cannot combine anything any further. And you can use the same thing even if your problem has more than two things to combine. So maybe part D here. So minus 6y cubed minus 9y squared plus 23 minus 7y squared plus y minus 11 plus 3y cubed minus 25. Okay, so the first piece, I'm just going to drop the parentheses, right? There's nothing to do out in front of the first piece. So we're just going to drop those parentheses and get minus 6y cubed minus 9y squared plus 23. In this second piece, I need to distribute this negative to each of these pieces. So we're going to end up with negative 7y squared minus y plus 11. And then in this third piece, it's a plus sign. And when you have a plus sign, you don't have to do anything except drop the parentheses. So you'd have plus 3y cubed minus 25. And now I'm going to go through and try to find the like terms. So the first thing I'm going to look for are all the y cubes. So here's a y cube. And there's only one other y cube. It's over here towards the end. So if I combine those two y cubes together, I have minus 6 of them and then a positive 3 of them. So it would give me minus 3y cubes. The next one, I have y squareds. So I have minus 9y squareds. Here's some more y squareds. Those are the only y squareds I have. So if I combine those together, I get minus 9 minus another 7 is minus 16y squareds. I usually like to go down in order of the powers on my variables. It's completely up to you. You don't have to. But so I'm going to do the y parts next. In this case, there's only one y part. So I'm going to have minus y. And then I need one more. So if you look, this is a number all by itself without a variable. This is a number all by itself without a variable. And this is a number all by itself without a variable. So I'm going to add them together. So 23 plus 11 would give me 34. And 34 minus 25 is 9. So I'd have that plus 9. So my final answer is that minus 3y minus 16y squared minus y plus 9. And that's all there is to really adding and subtracting polynomials.